Welcome back, Physical Science 20. This is PW2.3, reflection of sound waves in applications. So PW1, we looked at reflection of just regular one-dimensional waves, slope, ropes, slinkies, etc. PW2.2, we looked at reflection of water waves, and you had a video to watch there to answer the questions on the assignment. And now we'll look at sound waves. To provide examples and solve problems dealing with wave reflection in everyday situations such as echoes, reverberation, room acoustics, radar, sonar, parabolic microphones, and ultrasound. So we're basically going to do one example here. Then, of course, on the assignment, there's a few questions there, such as taking a picture with the camera that determines distance, looking at echo, and looking at sonar. I'll give you a couple of hints about this one. It's a little bit tricky. So look here, a hiker shouts toward a vertical cliff 465 meters away. The echo is heard 2.75 seconds later. What's the speed of the sound of the hiker's voice in air? The wavelength of the sound is that. And I think I meant to have these as combined because B really isn't a question. I'm just saying if the wavelength is this, what's the frequency, and then what's the period of the wave, the period of the wave. So we should sketch a little diagram just to see what is exactly going on here. So there's a cliff here. We'll just say here, we'll do this. Cliff. And here you have someone shouting, right? They're shouting. So their voice goes there and back. And we're told that the echo is heard 2.75 seconds. And that represents there and back. Because they shout, boom, boom, hear it 2.75 seconds later. So there's a couple of things we could do here. We want to figure out, we know how far it is. So to figure out the speed here, the time and the distance must coincide. So right now, we're told that the cliff is 465 meters away, and your voice to go there and back is 2.75. So either we have to double the distance to represent there and back, or take the time of there and back and just divide it by 2 to figure out just the time from here to here. And I think that's what I'll do there. It kind of makes the most sense there. We'll take 2.75 seconds divided by 2, and I get 1.3 seconds. And that is simply going one way. So the time to go to the cliff, 1.38 seconds. The distance from here to the cliff, 465. Because that's what you have to be careful with these reflection questions. Just figure out if it's there and back or just one way, and then go from there. So I have a distance, I have a time, so I can figure out the speed of sound that day. So I think it works out to be 337 meters per second. Distance divided by the time, and there we go. And yeah, B and C, we'll just make it one question because there isn't a question there. It's just simply saying we know what the wavelength is. What's the frequency? So wavelength is 0.750. I know the speed. So look at the frequency. And of course, this involves the old universal wave equation. 337 is equal to 0.750 multiplied by f. So of course he has to solve for f. Divided side by 0.75, and that works out to be 449 cycles per second, or simply hertz. And then lastly, what's the period of the wave? Of course, if I know what frequency is, I can figure out period. So 1 over 449, 0.00223 seconds. All right, so that's how you do that. And again, the key thing is look at the scenario, figure out is it there and back, just one way, etc. All right, to give you a few hints about that third question there on the assignment. So a ship surveying the ocean bottom sends sonar waves down into the seawater from the surface. So sonar works by sending a wave down, reflecting, and then by basically doing that calculation we just did with echoes, you can figure out how deep something is. If we know the speed of sound in water, the time there and back, time divided by 2, and we can solve for D. For the second reflection from the bedrock beneath the mud, it returns up to 2.36. So we're doing two things here. So sending time here, sending time here. How deep is the water? So first of all, if you take this time and divide it by 2, you'll get the time down. And the seawater, we're told, has a speed of this. So if we have the speed in seawater, the time in one direction, we can get the D. Okay? Then this part's a little tricky. How thick is the mud? So we were going to want to figure out the distance from here to here. So the key thing is we're going to have to know the time from here to here. So we can get that by taking this divided by 2. So we'll have the time down. And then subtract the time down that represents water. So you have your time down, your time down. This big time down, subtract the seawater time down, and you'll get the time in this region here. And once you have the time in that region there, we know the speed of sound in mud is 1875. Then you can rearrange and solve for D. Okay? So it's a sneaky little question there. So you should be able to do that. Just like how we did the first one there, and you should be able to do the 3 questions in this assignment. All right, we'll see you again.